Okay, we're about to dive into a paradox that honestly sounds like it's been ripped straight out of a science fiction script.
Yeah, it's a wild, counterintuitive idea, right? But what's the actual science behind it? Well, we're going to break it all down, so let's get into it. So, we're actually going to look at three totally different ideas that connect warming to cooling. The catch? They all happen on these vastly different timescales. Let's kick things off with the one that's most immediate and probably the one you've heard about. Now, this first theory, it's not about the entire planet freezing over. We're talking about a regional deep freeze, something that could happen, on a human timescale. And it all boils down to one critical piece of the Earth's, let's call it, plumbing system. And that piece of plumbing? It's the Gulf Stream. You can picture it like a gigantic, warm river flowing through the Atlantic. It's literally the reason why places like the UK and Norway are so much milder than, say, Greenland at the exact same latitude. It's basically a giant natural space heater for Europe. Okay, so how do you turn this thing off? Well, here's how it could work. Global warming melts the Arctic ice, a lot of it. And that pours this massive amount of cold, fresh water right into the salty North Atlantic. See, the problem is that fresh water is less dense. It just kind of sits on top instead of sinking like the cold, salty water is supposed to. And that just jams up the whole system. The conveyor belt grinds to a halt. And just like that, the heater's off. And the effect? Oh, it would be absolutely dramatic. We're talking average temperatures in places like the UK and northwestern Europe, potentially dropping by 5 degrees Celsius. That would plunge the whole region into winters that would feel a lot like the Little Ice Age. Just brutal. It brings to mind what the legendary oceanographer Wallace Broker once said. Climate is an angry beast, and we are poking at it with sticks. It's such a powerful image, right? It really gets at the enormous risk of messing with these huge, complicated systems we don't fully understand. All right, so that's the regional chill scenario. But now, let's pull the camera way, way back. I mean, way back. And look at a potential global freeze. This next idea plays out on a completely different stage. We're not talking centuries anymore. We're talking geological time. Tens of thousands of years. You see, for a long time, scientists thought Earth's long-term thermostat was this really slow, gentle thing. Rocks weathering over millions of years, gradually balancing things out. But some newer research has found something else entirely, a much faster, more volatile system hidden in the oceans. It's a biological loop that can basically slam on the climate brakes so hard that it completely overcorrects. And here's how it works. It all starts with warming. A hotter planet means more rain, which washes more nutrients from land into the ocean. All those nutrients, they act like fertilizer, triggering these gigantic plankton blooms. Then, when all that plankton dies, it sinks to the bottom, taking huge amounts of carbon with it. So that starts to cool the planet down. But, and this is the kicker, as all that stuff decays, it uses up the oxygen in the deep ocean. And a low oxygen environment, well, it actually releases even more nutrients from the sediment, which then fuels an even bigger bloom. You see where this is going? It's a runaway feedback loop that could, theoretically, suck so much CO2 out of the atmosphere that it kickstarts a full-blown global ice age. The geologist Andy Ridgwell has this perfect analogy for it. He says it's like putting the thermostat in your house in a completely different room from your air conditioner. The AC just keeps running and running, not realizing the room is already cold. And it ends up overcorrecting and making the place an icebox. That's kind of what the Earth might do. Okay, so let's recap. We've got this potential regional chill, right? And then we have this possible deep time geological freeze. But there is a third character in this story, a huge one actually, that's on the stage right now and is completely rewriting the script. And that character is us. And here's the fundamental issue. The carbon dioxide we're pumping into the air, it doesn't just, go away after a few years. A big chunk of it stays up there for an incredibly long time. We're talking over 100,000 years. That creates this long-term warming pulse that's just completely off the charts compared to recent geological history. Okay, so here's a super important point about how ice ages even start. They aren't random. They're kicked off by these natural, predictable wobbles in Earth's orbit. An ice age can really only get going when the summer sunlight in the northern hemisphere becomes just weak enough that it can't melt all of the snow from the previous winter. But all that extra CO2 we've added acts like a big, thick blanket wrapped around the planet. And with that extra insulation, the summer sun has to get way, way weaker before snow can start to stick around year after year, We've basically just cranked up the difficulty setting for starting an ice age. And the effect of this is, well, it's staggering. Just look at this. On the left, you've got what would happen naturally. The next ice age was probably due in about 50,000 years. But on the right, in a high-emissions world, that CO2 blanket could be so thick that it basically cancels ice ages for 500,000 years, maybe even longer. And listen, this isn't some hypothetical future problem. The science suggests that the emissions that are already in the air right now have likely pushed back the next ice age by at least 120,000 years. Think about that. We have already, fundamentally, messed with Earth's geological clock. So, wow, where does that leave us? We've got this regional chill idea, the crazy geological overshoot idea, and now this massive postponement caused by us. How on earth do all these pieces fit together? Well, it really all boils down to one thing: timescale. The Gulf Stream shutdown, that's a real near-term risk that could cause regional cooling. That whole planetary overshoot thing, super interesting, but it's a very distant natural possibility. But the big one, the dominant force right now and for thousands of years, that's the warming from our CO2. It's the one that's overriding everything else and stopping the natural cycles in their tracks. So let's circle all the way back to the question we started with. Is an ice age coming? The answer is yes, eventually. But here's the twist. It's not coming because of global warming, it's coming in spite of it. Our warming has basically hit the snooze button on the next ice age for a very, very long time. And this, right here, is probably the most important thing to take away from all of this. These fascinating, long-term planetary dynamics, they aren't some get-out-of-jail-free card for the climate crisis we're dealing with today. The threat of a regional chill in Europe or a deep freeze 100,000 years from now does absolutely nothing to change the immediate reality of a planet that is warming up fast. Look, the Earth has these incredibly powerful ancient cycles. It does its own thing. But what we're seeing is that for the first time, our actions are powerful enough to throw a wrench into those cycles on a geological scale. So the real question isn't about what the planet will do in 50,000 years. The question is, on the timescale that actually matters to us, to our kids, can we really afford to just keep poking that angry beast?